event where we meet up with the community, we answer your questions, we chat, we have a drink, yeah, and get to know you all. So today we'll have Bo giving a talk about Finetuner. I think that'll be the first thing. And then, yeah, we invite questions about Jina, about your use cases, about all the stuff in the Jina ecosystem. All right. Are you good to go, Bo?
Yes, I'm ready.
He was born ready, folks. Actually, he was born Bo, but you get the idea.
Shall I share my screen? Okay. Can you see my screen? It's gonna be a very quick one about the upcoming release of the Finetuner. So I will start from here. So maybe as community members, maybe you have realized that the open source version of Finetuner has been stayed there for a while. The latest version is 0.4.1, but actually internally, we turned it into a closed source project. It has been rolled out to 0.7 version. So we made a lot of changes, and in this presentation, I'm going to give you a quick update on the Finetuner upcoming release. So yes, so a little bit about the background. So Finetuner for search is always non-trivial. So giving us a list of reasons. First of all, the pre-trained models work for building prototypes, but not for production. We have been verified it through a lot of failure cases of the projects we work with our partners. And people with search background sometimes lack of knowledge on deep learning. Search background, I mean information retrieval. On the other side, people have deep learning knowledge, such as computer vision, natural language processing. They do a lot about they do not care a lot about search. In most of the cases, they care about classification, sentiment analysis, name entity recognition, this kind of tasks instead of search. So different backgrounds are needed when applying deep learning powered for search, such as information retrieval, natural language processing, vision, and multimedia. So that's why we say Finetuner for search is non-trivial. But now the Finetuner comes to rescue. So how the fine-tuning comes to solve the distribution shift issue. So we have a pre-trained model. Imagine you have a pre-trained model trained on the ImageNet dataset, then you want to use it in your maybe fashion dataset. It doesn't really work because you have the different data distribution over your trained dataset and your target dataset. So this thing doesn't work. Fine-tuning is able to solve the distribution shift issue by adopting the pre-trained model on your task of interest. And Finetuner use contrastive approach to do model fine-tuning regardless of the data modality. I will show you a little bit later. And the Finetuner is very easy to use. As long as you have a Jina document array, as long as you are a document array user, and learning Finetuner is very, very easy. And only a little machine learning knowledge is required. So you basically do not need to know machine learning, but you can still fine-tune a model. So you might be wondering, what's the difference between the Finetuner and other deep learning frameworks? So here are some reasons. So here I compared Finetuner against, maybe you have heard of that, transformer trainer. The Finetuner aims at fine-tuning an embedding model. So an embedding model outputs for better embeddings, but for general machine learning frameworks, they are aimed at fine-tuning a specific downstream task. For example, if you have a pre-trained model on the ImageNet, which is 1,000 classes, then you want to fine-tune it for maybe dog, cat classification. So you are fine-tuning you remove the previous 1,000 class classification head and try to fine-tune these 2 class dog, cat classification head. So your output is classes, but the Finetuner output is embeddings. This better embeddings is for search task. And Finetuner takes any model as input. It could be just a simple multi-layer perception, or it could be a convolutional neural network or a transformer. such as BERT or even transformer model provided by Hugging Face. And instead of Finetuner, it converts this model into an embedding model by removing the head. And transformer trainer, for example, only can train a model based on the transformer architecture. On the other hand, Finetuner is optimized for search tasks by leveraging contrastive metric learning. This kind of transformer trainer is optimized for general tasks, such as classification. So you have cross-entropy loss, or you have different other kind of losses functions or other tasks. It's more general, but Finetuner only optimized for search tasks. This is how the basic idea of Finetuner. So imagine you have some supervision, you have some data with labels. Here, supervision means labels. And you have an anchor document, you have a positive document, and you have a negative document. Finetuner will try to build this kind of triplet based on your document array and trying to push together the anchor document and the positive document and push away the anchor document and the negative document, able to bring better search result. This is the basic idea of how Finetuner works. And what we are delivering now is basically fine-tuning as a service. So there are some reasons why we closed-sourced the current Finetuner. For example, the Finetuner becomes a stakeholder of several Jina internal projects, such as Jina Now, 𝗏𝗏 as service, docsqa, and some unannounced projects. So this kind of internal projects will be using Finetuner to fine-tune a model and then provide solutions to other users. But in the meanwhile, we will also release Finetuner to the external customers. So you can just use Finetuner. You don't have to care about the machine learning part. You only care about the search quality with minimum configuration. And you don't have to worry about how all the CUDA, all the GPU, all the CPU computational resources to conduct fine-tuning. Finetuner will do that for you. Our design objective is we care about model performance, but we are not chasing for SOTA. We are not chasing for state of the art. We try to find a balance point between the performance and the stability. And user needs to stay inside Jina ecosystem. So Docker array is the entry point to prepare training data for Finetuner. The output can be directly applied to Jina products, such as 𝗏𝗏 as service. So after you fine-tune a model, you can just load the model from 𝗏𝗏 as service. And the last one is you only provide very minimum configuration, which allows users to control their experiment. But apparently you can do more if you have better knowledge on machine learning. But most of the parameters or hyperparameters are optional to the user. So after around 3 months of hard work, giving a very small team within Jina AI, we have a Finetuner team. This is what we have now. Previously, we only have an open source Finetuner, then we stopped there. And now what we have is firstly, we have a closed source Finetuner core. So this core part is the algorithm part, how we conduct fine-tuning. In this Finetuner core, we have a much improved Finetuner core with transformer support. We support fine-tuning 𝗏𝗏 model with much faster training on a single GPU and across multiple GPUs. And we have done a huge amount of code refactoring and bug fixes. And beyond this Finetuner core, we have a new Finetuner API. This Finetuner API handles all the cloud jobs, resource management, such as GPU, CPU, memory, to conduct fine-tuning job. And it allows us to submit a Finetuner job in the cloud. And it has deep integration with Jina's user management system and cloud storage system. And on top of these 2 closed-sourced projects, Finetuner team also is going to release what we call an open-source Finetuner client. So this is basically the Finetuner. The Finetuner user is going to interact with. It will be open-sourced. It will be published to PyPy, not yet. And it will be replacing the current open source version of Finetuner. So this figure elaborates a little bit how the Finetuner works. So imagine you as a user, you start from here as a user. You will first call to log in into the Jina ecosystem. This is apart from Finetuner team, but you first log in. Then you can push a document array into what we call 𝗶𝗶. So here you store your training data as an artifact. And when you want to start a fine-tuning job, you are basically creating an experiment. And inside this experiment, you have different runs with different hyperparameters configurations. For example, you start a run, then Finetuner API will spin up an isolated computational resources. You can imagine a small machine in the cloud. And in this isolated cloud, it will pull the data from our 𝗶𝗶 back to this machine. And it will also run the Finetuner core, the algorithm part, inside this machine. So it will actually run the tailor, which will convert your model into an embedding model and run the tuner to fine-tune your model. After that, it will automatically push your tuned model back to your artifact storage, which is managed by the Jina. And this artifact is only available for you because now you have logged in and we are using your token to push the model to the cloud artifact storage. You can always monitor the loss functions and everything using third-party libraries such as WebSockets or MLflow. In the end, if you think this model is ready, then you can pull this model back to your machine. The user story is going to be very easy. This is everything happens underneath. You don't have to care about everything here. But what you have to care is how easy it is to use. So what you need to do is just import Finetuner, which is the Finetuner client. You can call finetuner.login. It will basically get a token from Jina ecosystem. Then you prepare your training data as a document array, as I mentioned before, because the document array is the only acceptable format by Finetuner. Then you can call finetuner.feed. The only two parameters you need is first one is model. So which model you are going to use. In case you don't know which model to use, you can just call finetuner.list models. It will suggest model for you. And you can plug in your training data into the finetuner.feed. Here are some optional parameters. If you want to set that, you can just overwrite it. Otherwise, we will configure it for you. Then you can see the run.name, get run.status, or to look at the logs by calling run.logs. You can see when the fine-tuner is ready, when the fine-tuning process is ready, you can just call run.save model and save it to your local. It will basically pull the tuned model from the cloud artifact storage back to your local machine. That's how Finetuner is, how it can be used. It's very easy. So the most difficult part has been handled by the cloud and the Finetuner core, the algorithm part. And how much, the last thing is how much performance gain you can expect. It actually depends on a lot of factors. Internally, we have conducted a lot of experiments on various tasks, such as image-to-image search. So image-to-image search, we call it content-based image retrieval. Or text-to-text search, you use text dense embeddings to search for dense factors. And cross-modal search, you use text to search images, or the other way around. So basically, there is no text descriptions linked to the image. You directly use the text to search the cross-modality to search the image. And across all these three tasks, Finetuner is able to boost 20 to 45% of precision at K and recall at K. Here K, which is 50. You can also observe a significant performance improvement in other metrics as well, such as MRR or NDCG. That's how much Finetuner can bring you after you run this simple script. But it also depends on your size of training data and the quality of the labels, etc. But this is something we have done internally. And last but not least, if you are interested in Finetuner, feel free to reach out to Shia in Slack channel for the beta testing. We haven't released the Finetuner client yet, but it will be coming in next week. That's it. Thank you.
Thank you, Bo.
Thank you.
All right, fantastic. So, yeah, do we have well, first of all, I know we have questions, but do we have any questions specifically about Finetuner? Let's start off with those. Either speak up or drop a message in the chat. As Sophia says in the chat, if you have tried out Finetuner, we've got a form that you can fill in. We'd love to hear your feedback. It always helps us improve what we're making.
Quick question with regards to
Vincent, we can't hear you.
Oh, am I unmuted? Can you hear me now?
No, we can hear you.
Yes, we can hear you. Yeah.
Ah, right.
All right.
Sorry, yes, I'd muted my own laptop. I'm an idiot.
No worries. So in the case where you're talking about optimizing a given model, let's say we're using Clip as a service, and then we want to leverage that optimized model. Is this only going to be pushed in the cloud, or is there going to be a way with Clip as a service to have a optimized version or a fine-tuned version to be used?
Yes, the model will be in the cloud, so it will be always saved into the cloud until you delete it. And otherwise, you can also pull this model back to your machine. So Finetuner.download model will download this model to your machine. So then inside Clip as service, you can just replace the pre-trained model with this fine-tuned model. So everything should work.
Okay, perfect.
Yeah.
Thanks.
Yeah. Thank you for your question.
All right, thanks, Vincent. Any more questions about Finetuner? Okay, I'm hearing cricket. Do we have any other questions about using Jina? I know Pratik might have some.
Yeah. Hi, Alex.
Hey.
Yeah. So I've already posted the question. The question is, I mean, we have a use case where what we are supposed to do is that the supplier which mentions the product description inside the invoice, we're supposed to map a right HS code. So you understand what is HS code? A homogenized system. So every product has a unique HS code. So what we are supposed to do is, there could be a unstructured text that is present. So you call it a shirt, okay? So a shirt might be something different, or you may call it a shirt by a brand name. Or let's take an example of an iPhone. iPhone is a smartphone, right? But most of us call it as an iPhone. So these are the things that are, I mean, the right description is supposed to be mentioned in front of the government agencies whenever you're doing some compliance with regards to a government agencies. So we've got a use case, just we are struggling that will it fit to be a neural search enabled thing where we will be using a neural search to find out the right HS code basis on the product information or the description that is mentioned inside the supplier invoice.
So essentially a classification issue, taking an arbitrary text string and mapping it to an HS code.
Yes, yes.
And how many HS codes are there?
There are more than 20,000. More than 20,000. Every country has unique set of HS codes specified to their own countries.
Right. So not so harmonized, just semi-harmonized. Right. I'll throw that over to our trusty engineers. Anyone want to pick that up? Anyone? Anyone want to speak up? Come on, people.
Hey, hello. What was the question?
Sorry, Pratik, could you just recap the question?
Sure. So, hi, Florian. So the question is, the question is that we, on one hand, we have a product description, which is mentioned in a very raw format, or there could be a brand name in front of that. So take an example of an iPhone. Okay, so iPhone is what, and a supplier may be putting as a product description. Okay, maybe a brand name of an iPhone. And what we are supposed to do is we're supposed to map it with I mean, something that has been defined by the government or the regulatory authorities, that iPhone is a smartphone which is less than, say, 6 inch or 4.7, whatever the screen size would be, the display size. So yeah.
Okay. So yeah, I heard this description, but so what is your actual case behind? So I hear that you would like to replace these words, these different words with like smartphone, and then to have some normalized text or something. What's your actual use case? Is it a search case?
I think, can I explain it a bit more technically?
Yes, sure, Sumit,
Yeah.
go ahead.
Florian, hi. This is a colleague of Pratik. So we are working on the same project. So here we have two different data sets. One is a descriptive, like where you have a product and a description. And on the other side, we have a description and the HS code itself. So whenever we have two data sets, based on the descriptions having on the products and the HS code descriptions, right? So based on
you would like to retrieve the product. Is that correct? Right. So you would like to retrieve the product. So you have.
No, we would like to retrieve the HS code. We would like to retrieve the HS code based on the product description. So whenever any user wants to export his product, right? So he'll say like, yeah, I need to export my iPhone, and he'll put some descriptions for that phone, that smartphone with 4-inch screen and different features and all those things. So based on those specification or the description, we need to roll around these HS code descriptions, and based on the description matching, we need to find out the right HS code for that product which user wants to export.
Yeah. So Florian, are you able to see the screen?
Yeah, I see the screen with a lot of numbers and
So I'll just pick up a random product description. So this is coated galvanized steel sheet in coil, grade 𝗔𝗶𝘂, whatever it could be. Okay. So coated galvanized steel sheet is the one that we need to find the HS code for. Okay. Now what I'm doing is I'm going to chapter and this is what may fall under chapter.
Just a small hint coming from Sophia. So this is a stream, and just be aware that you don't share some public data because everything is recorded, just in case you're not aware.
Sure.
Streamed. So yeah, be very careful.
Yeah.
Sure. So yeah, I mean, what we are supposed to do is we're supposed to search in this PDF documents and then come to a conclusion that this is, I mean, it could be from either of the lists that are mentioned here. So this is chapter 27, meaning the description starts with 7.2, and it could be anything, say chromium type or nickel chromium, authentic type. There are different names that are present here. So we just are supposed to come to one conclusion out of all these things. So
yeah. So to me, it looks like there is some manual parsing you have to do of this document, where Jina cannot be helpful because like we're building the framework, and you cannot we cannot have like a document parsing for all kind of use cases. So this would be on you, and then also finding these matches, these ID matches. Sounds to me like there is exact string matching required, and no approximate nearest neighbor, or am I mistaken somehow?
So is the input string an arbitrary string of text written by the person supplying the thing, and then that has to be matched to a code? So maybe the person typing it would do iPhone or iSpace phone, or misspell things, or say inch or inches. So it's a completely arbitrary string of text that has to be classified into an HSN code.
Yes.
Right.
And is that spreadsheet that you showed, is that what you want to generate, or is that also something that you already have and you want to match an arbitrary input?
We need to find out the matching items out of that spreadsheet.
So the spreadsheet should be the output of what you're trying to achieve.
No. The PDF that I showed you should be the output. I mean, either of one is supposed to be mapped with it. So the spreadsheet is actually an unstructured data, which could have a brand name in front of it, or there can be different codes along with any of the keyword that is matching with the product, but it could have other codes also. So you're actually supposed to work on that string and then run a query on top of it.
Okay, but the data that is in the spreadsheet, so the mapping from the number to this description that we saw in the spreadsheet, that is something that you have access to and can store somewhere, right? Am I understanding correctly?
Can you please repeat?
So the spreadsheet that you showed us, which basically is a mapping from these numbers to some description, that is something that you have and can use during your search. Okay, then I think, and guys, correct me if I'm wrong, if I understood correctly, you would have to just parse your input. Then you could put it through a language model. And in the same way, you would put these text descriptions that you have in your spreadsheet into a language model. And then I guess you could try to find the arbitrary input embedding and match it with the embedding from the text in the spreadsheet. And so you match text to text, and then you have the text in the spreadsheet. And from that, you can get the number that is also in the spreadsheet.
Yes. And also to add, I mean, let's say the PDF where we are searching, I mean, which provides us an output. Let's take an example of a lubricating oil, okay, which falls under a chapter maybe 27 or 36 or 27 usually. So there are different chapters on which different products are categorized. So there could be a keyword entered as grease, which is given as an input. So grease as a keyword is not at all matching, and it is not at all present in the PDF that are mentioned by the customs authority or by the government authority. So what we are supposed to do is that grease is supposed to be, you need to find a synonym for a grease, which could be a lubricating oil or lube or anything similar to, I mean, the different synonyms, and then try to at least give that suggestion that this could at least fall in chapter 27 or 34 maybe.
Mm-hmm. So what would definitely work is having some text and automatically through neural search map that to some other text. With doing the synonyms and everything, that would definitely work. And then once you have that, then you have to map to these IDs. What will probably not work, or at least not be very useful, is taking a text and trying to map that directly to the IDs. I don't think would work well.
Okay.
I think, not sure if anyone else has something useful to say about this. But does that make sense as an answer to your question?
Yeah.
Okay. It looks also like the document should be processed quite a bit to make it useful, as opposed to trying to find the right chapter directly in the document.
Yeah, definitely. Good point. You will have to extract like the sentences or maybe paragraphs, but most likely sentences, or like the specific descriptions of the items. You'll probably have to extract those first. Yeah.
I see. Okay.
All right. Thanks for the questions, guys. Do we have any more questions from other folks?
I have a couple, but maybe you can let Saverio go first.
Oh, thanks, Vincent. Sorry, I actually was late to the call. Yeah, just a quick one. I have an issue with the Docker for DALI Flow. Just downloaded, installed everything correctly, so it's finally working everything properly using also the client notebook. I'm really happy about it. Spend a week, but so really good job, guys. Thanks, obviously, for this. Just wondering why. So I'm having an issue with the upscale, with the upscaler. So I installed the Docker, and then I run the client from the notebook. So I just try to basically. So when I install the Docker, just building and everything runs correctly, but then the upscaler is throwing an error, which I try to change the path. So I think like join reply to my thread here to the issue, but I'm just gonna send you this one, the link in the chat. But yeah, so I changed the path, put the absolute path in the Swin IR path. But then I'm still getting the same errors. Just can't really figure out from where it's coming from. Because I was checking inside my instance, so I can see. I don't know if you can. Maybe I can project my screen. Let's see.
So did you try to get inside the Docker container and run Swin AR on its own? Hello. Guys, do you hear me?
Yep. Yep, we hear you.
Saverio, I think you're muted. If you want, I can unmute you.
Oh, sorry, I think. Can you hear me now?
Yeah,
Yep.
yeah, now we can.
Okay, sorry, was the screen share? Yeah. Sorry, say it again, please. I didn't.
No, so basically, you can get inside the Docker container and do all this debugging by yourself inside the container. I mean, so you just, for example, run the Swin AR script, and you can provide him the path, right? And then you will be able to see if it's something with your usage with Swin AR, or whether the path is actually valid or not.
Yeah, no, that makes sense. I will try that out, but I'm just throwing just don't really can figure out why if I like follow all the installation that was working before. Yeah, just can't figure out if I follow the same steps in the installation of the Docker, and now like something changed maybe in the path, but okay, I will try. I will try that. By the way, I put the absolute path here. The thing when I went to inside the folder, went inside checking the Docker and in the instance, I don't really have this results folder. So I wonder if that's the issue, but I guess this is something that should be created automatically.
Yeah, maybe. Probably.
Okay. Well, thanks. I'll try this and keep you guys posted.
Awesome. Thank you, Saverio.
Thank you.
So I had a question with regards to the �we_aviate document store. So for some reason I might be missing something, but from what I understood of the documentation, if you instantiate your document array store with the configuration showing the class name, it should pull out the reference to what's in the �we_aviate store at a certain time, correct?
Yeah, right. So
Okay.
if you don't provide a class name, a random one will be created inside your �we_aviate instance, and if you provide the class name, it will use that one.
Okay, because I took that assumption, and I'm running a very simple example where, well, let me just share my screen, it might be easier. What's happening is that it doesn't seem like it's keeping the reference to the actual data, and the storage has the right length or count, but it's empty. Can you see the screen?
Yeah.
Okay, so if I'm instantiating the store here with the name. And I look at the summary, it has a length of 4 because I ran it already, but I'll just add those 4 documents to it. I can find the actual document by searching through, but then if I kind of recall the same thing here, you'll see that when I do the summary, it actually doesn't have documents.
Let me link you to the solution for this.
Okay.
Just a second.
Maybe in the meantime, while Alvin is looking, is it planned to have a health probe on the clip as a service, so that instead of trying to call it, seeing that it's not ready or it's unavailable and having to trap the error that comes from it, would it be possible to have a health probe endpoint that we could ping to see if it's actually healthy or not?
Yeah, we're actually working on such a feature. It will be first added in Jina Core and then added to Clip as a Service, which rely on Jina Core.
Oh, okay, perfect. That's great.
Yes, so I just sent a link in the discussion. Basically, what you are missing in your usage is the context manager. So you just add one line with the A, and then inside this context, you can append or extend or do whatever. And when you exit the context, everything should persist in your document array. Okay.
The context manager. One second. I'm just looking at the link you sent.
Yeah, you see the lines in yellow. Do you see that?
Oh, using a with statement around it. Okay. So it's going to persist the result of the operation when it leaves the with statement in essence.
Yeah, but make sure that you don't use with statements inside the for loop, but instead you wrap your for loop with the with statement. Okay.
Okay. So then essentially all the operations to the document store should be done within the scope of a with statement.
Yeah. Yeah.
Okay, got it. I'll try that out. Thanks. I was starting to wonder if I was crazy or anything. The other question that I had was with regards to data classes support. So the data classes were great in Docker, and I was lining up the usage of this for multiple things. When I got into executors, so that there's not a full support with the data classes. Is there a plan to have full support, or it's gonna always stay with partial support?
Currently, we are trying to push forward the data class feature and fully support multi-modalities. And of course, there will be upcoming features in core to further support data class, but I'm not sure in which direction we can go. So I cannot give information if this can help your specific problem, because as I remember, you want to convert root document to data class, right?
Well, yeah, so how I was using it essentially is leveraging data classes to just make first the conversion from an external entity coming in into a multiple sub document store into the document array, but afterwards if I want to take the result of a vector search and I just want to reconvert just the output of those doc arrays, the documents back into just the data class object that I can just output out with, let's say, a title, a text, an ID, and an image URL, for instance. Now it's not great to not be able to reconvert it back. So and then the access of the sub documents through the referencing that's usable in Docker arrays was also very practical. So just wondering if that's something.
But do you need to convert back to data class inside the executor, or you can do this in the client? What is the scope of the conversion?
Oh, I see what you mean. So what you're saying is that keep on executing the processing in the Docker array, and then at the outcome of the flow, take the doc array and then reconvert to the data class and push it out.
Yeah, at that point, it is possible to perform the conversion back, and I think it makes sense to convert back at that point because you want to render your results, right?
Yeah, exactly.
But inside the executors, currently it is not possible to convert root documents to data class.
Okay.
But of course, inside the executors, you can operate on each attribute and you can access each attribute.
Yeah, I ended up in the meantime just creating a chunks collection to avoid having the supportability issue with the conversions. But I'll try to just create the conversion before getting into the executors process, and then at the output of the executors do the reconversion into the object. I'll give that a try.
Yes, exactly. That's how it should be done.
Okay, and finally, for pre-processing images, would you recommend resizing before getting into a Jina flow and sending an image either as a byte stream that's already pre-processed in terms of size, or would you manage the resizing of images within the context of Jina?
So are you asking about resizing in terms of quality or performance, like speed of execution, or you want quality for model?
Well, I'll give you an example. So let's say somebody's taking a picture of a meal and from his iPhone, and it's a 5 megabyte image, and he's pushing it through the application. To reduce the amount of interactions and transformation on the image, would you, from the get-go where it's uploaded or it's pushed through, process a resizing right away, and then going down the pipe into Jina, the input to a flow would be an already resized image? Or do you think it would be more advantageous for performance reason or others to resize the image into the Jina context?
Okay, I see what you mean. So I would say if your image are pushed to some let's say CDN or a storage bucket, I think it's fine to just send documents with URIs, okay? And then inside your flow, you can convert that to image and then perform processing. And I would say as soon as you compute embedding from the image, you can, of course, it's very possible, you can just empty your documents from image content if you want to optimize your network traffic further. And I think this makes sense, but you also need to consider that if you perform resizing inside Jina, it is possible to add replication, and this can also present performance benefits for you. But it's not only the trade-off between network bandwidth and also between processing of the resizing.
Yeah, because the thing is let's say those images are come from user-generated content, and the purpose is not necessarily to retain those images. So I was thinking of keeping it kind of in memory, resize in memory, sending it into a Jina flow, but never necessarily keeping a track of that image in the future. It's as if it was a search query, right? Instead of being a keyword, it ends up being an image. So I was just wondering, the best path to your point, a balance between performance of processing the image inside a Jina cluster, for instance, versus pre-processing it before and keeping it in memory.
For me, like if your application is running on an iPhone and you are like really high quality photo, then it kind of makes sense to downscale the image before sending to the model, because usually the model will work with like 224 image pixel.
Exactly.
And like it does not make sense to send the image with 10 megabyte to the executor, which only need like 100 times less. So if you are in this like proportion, like iPhone full quality image, and you for example using Clip as a service, then it makes sense. Now, if you are like having images around 500 by 500, I think it does not make sense. If you're like really close to the destinations, then you can just do it on Jina. But if it's really like iPhone image, then I would say resize before.
Pre-process before for the resizing. Okay,
yeah.
Good. Yeah, I think for now that's good. Thanks.
Thank you, Vincent. Any more?
Maybe one last one. Sorry. In the we indexer executor, there's an assumption that the update, if the document doesn't exist, it triggers an error. Would you, if you were to identify if the document exists before, how costly would that be? So if you, let's say you don't know if a document that needs to be indexed exists or not, is it better to try to update, and if it doesn't update, you create, or to do a find to find it by ID and then update or create? What would be your recommended path? Because I know find can be an expensive function, but I was just trying to see, because the approach that I was thinking was taking in the inputs, searching to see if those IDs map into the index. If they are, then you update them. If they don't, then you create them in the index.
So in this example, do you need upsert operation, or you only want to update if it exists?
Well, that's it. That's exactly the thing I was wondering, because I want to avoid for first to have any degradation on the index by avoiding any duplicates for sure. But if I have an update that has a combination of records that exist already and records that don't, I need to find a way to see if they do exist or not, and that's where, so it would be an upsert capability.
Okay. I think if you need upsert, then it makes sense to try update, and if there's an error raised, you can just call the create endpoint.
So you would recommend triggering the error, and then create, versus doing a find?
Yeah. I don't think it makes sense to perform find, because if you do find, then you have to request in every call. But if you attempt and create in case it fails, well, when it exists, you have 2 calls, and when it doesn't exist, you have only 1 call.
Okay, I see. So the cost of the error isn't that expensive compared to a find, is what you're saying?
Yeah. Not.
Okay, got it. So you would need to do that run document per document though, not on batch.
Do you need like batching in this case?
Well, I'm just saying in the case you would do, let's say, hundreds of document updates, you would need to run them in a loop in that scenario versus doing a search for a batch of, 1,000 IDs. You get only the IDs that exist already that you have to update, and then you create the balance in one go.
I see. Yeah, maybe in this case it would make sense to have an upsert endpoint, and therefore you avoid like this would give the best performance.
Okay, so it doesn't need to be in the we aviate indexer executor. I actually made my own, but I was just wondering, if it was better to go one way or the other compared to what you have done. So essentially, if there's a big batch, it would be better to go my route. But if it was an individual update or create, it would be better to just trigger the error with a single record.
Yeah, but if you have a batch, I think it's the best solution is to have an upsert endpoint, and by upsert, it updates if it exists and creates if it does not.
Yeah. So it kind of combines so for a single record, it would be an upsert which tries to update. If it doesn't exist, it creates. And then if it's a big batch, it would go more of a find operation for the batch, take the subset that exists already and updates them, and take the other balance and creates them.
Yeah, but yeah, this does not exist in the rebate indexer, right?
Say that again?
I said this logic that you just described does not exist in the rebate indexer.
No, it doesn't. I created it. It works. I was just wondering from a performance perspective, the cost of the find for a batch versus the triggering of multiple errors.
Yeah, I believe that Weaviate is capable of performing upsert. So you need to implement an upsert endpoint. That's my opinion.
Okay, got it. Thanks. That's all for me.
Okay, any more from anyone else? Okay, Sumit, Pratik, any more from you guys?
No, Alex, we're good. Thank you.
Perfect. All right, then I guess that's a wrap. Sophia, when's the next office hours? Fill us in here.
We haven't set our next office hours yet, but usually it's on the last Thursday of the month at 7 p.m. So all the information you can find on our Slack channel, and also if you follow our meetup, you will see all of the latest events in there. If you are someday in Berlin, we're hosting offline events every month together with PyData Berlin, so feel free to join us there as well. And yeah, let's keep in touch with all of you on Slack. Thank you so much for joining tonight.
Thank you.
Thanks, everybody. Have a wonderful evening or morning or afternoon or whatever it is, wherever you are. Bye-bye.